today's lesson is 49, solving rate problems with proportions and equations. What's our objective, class? Get ready?
Solving rate problems with proportions and equations.
Very good. Today we're going to carry on off of what we did yesterday. We worked with proportions yesterday and we solved for missing things. We used ratio boxes with totals. Today we're going to talk more about unit rates and how we can take those proportions or those ratios and turn them into unit rates and then write an equation from the unit rate. So let's just recall. Unit rates are ratios of two different units, miles and hours, where the bottom unit is 1. That's called a unit rate. What is it called? Get ready?
Unit rate.
Unit rate. So I could turn 100 miles per 2 hours. I could turn it into a unit rate by dividing 2 into 100 to get a 1 on the bottom. Right? I could take 200 and divide the 4 into that 200 to get a 1 on the bottom, and then I would have a unit rate. So we're going to be doing problems just like that today. So let's take this scenario. If six books weighs 15 pounds, how much would 20 books weigh? So you're going to fill out just like we did yesterday. 6 books weighs 15 pounds. This is books. How much would 20 books weigh? So 20 goes here, and the question is, how much would that weigh? Well, it's a proportionate relationship. The book's the same size, so it's not going to have a weird mystery weight. It should be proportionate. So we're going to set up our quick proportions. 6 over 15 equals 20 over x. How do I solve proportion? Remember yesterday's lesson? What do I do? Maddie?
20 times 15 divided by 6.
20 times 15, so we cross product, and then she says we're going to divide by 6 next to get x isolated. And then let's type that in. Who's got their calculator? Can punch that in? Alex.
So that would equal 50.
50. Let's just check if it makes sense. We'll throw our units on there. 50 pounds. If 6 books weighs 15 pounds, would it make sense that 20 books weighs 50 pounds? I like to think of it like, well, let's see, 15 is like a little more than double the 6. Is 50 a little more than double the 20? Yeah, so it's proportionate. It makes sense. Lucas.
But because 6 and 20, so you could just do 3 and 10 because 3 is a multiple of 15.
Okay.
You could just,
So you're thinking, hey, right off the bat, I could go like that?
yeah.
And then that would, we still would have to do some multiplying and dividing.
How'd you get a 10 there?
Oh, did you divide this in half?
Well, so 3 is a multiple.
You could do it like that. Is that what you were thinking?
No. So because 6 and 20 is the same as 3 and 10.
Okay.
So, and then 15 divided by, and then 3 is a multiple of 15, and so you can just do it that way.
Okay, that's another mental way to do it. Jake, save your comment. We're going to move on. Okay, so part B, it says, what is the unit rate in pounds per book? That's the giveaway. It says pounds per book. So I'm going to write pounds per book. That tells me what to put on top and what to put on bottom to find my unit rate. Pounds, let's pick the easy one with the zeros. I'm going to go 50 pounds over 20 books. This is pounds, this is books. And I'm going to just reduce that or divide 20 into the 50. And I like to reduce first because it makes it a little easier to divide. 5 divided by 2, 2 is going to go in 2 times with the remainder, but we're going to call it 2.5. My units are pounds per 1 book. When my denominator has a 1 in the bottom, it's called a unit rate. What is it called when we have a 1 in the bottom? Get ready?
Unit rate.
Unit rate. So now part C says, what is the rule for how to find the total weight? So meaning, if I had a bunch of books and a weight, if I had 1 book, we just said it's 2.5 pounds. If I had 2 books, what would 2 books weigh? Think. Get ready?
5 pounds.
5 pounds. If I had 3 books, what would 3 books weigh? Think. Get ready?
7.5 pounds.
Good. I think you guys got this. 4 would be what? Get ready?
10.
10. Okay, what rule, what were you doing to the 1 to get 2.5? What did you do to the 2 to get the 5? What rule did you use? Colin.
Multiply by 2.
Multiply by 2
And
and a little bit more.
2.5.
2.5. Does it work for this one? We have the same rule every time. Yeah, that would work. multiply by 2.5. So the rule is multiply by 2.5. So this is write an equation. Sorry, that's my rule. Part D, write an equation. I would say to find the weight is equal to the number of books times 2.5. I now have an equation and it uses the unit rate. I could rewrite it with the coefficient in front. Okay, weight equals 2.5 times B. Give me a thumbs up if that mostly made sense. All right, very good. Let's do another one. This one's a bike race. I just bought me a new bike, kind of for my birthday last month, and I have to wait all winter to ride it. But this is a road bike. You ride a lot of miles on these bikes. So here's a bike race that was 50 kilometers in length. The question says, if I had ridden 15 kilometers and it took me 27 minutes, how long would the whole race take? So again, we have another proportion to set up. On your papers, would you write me a proportion? Put your pencil up when you've got it. Okay, what proportion did you write, Kenzie? So you've got this number and a missing number, and this one, and it's a proportionate relationship. So how do I write a proportion out of these four numbers? We did this yesterday. Colin's going to help out.
Do 50 over the missing
Over the
number,
missing.
which would kilometers, yeah,
Okay.
which equals 15 over 27.
So in other words, whatever order it's written in, just keep that same order, just pair them up together. 50 to the time should equal this distance to this time, because it's a proportionate relationship, right? Make sense? Okay. So now to solve that, we're going to take a quick cross product. 50 times 27 equals x times 15. We're going to divide by 15 to isolate x. Do it to both sides to keep a balanced equation. We get x equals, who's going to type that in for us? We should all type it in. Who's got it? Raise your hand. All right, Kenna?
90 minutes.
90 minutes. Let's check it and see if it makes sense. If I biked 15 kilometers and it took 27 minutes, that's almost double. Is 90 almost double the 50? Yeah, it's proportionate. It makes sense. That's why these proportions work and help us out. Okay, that was the first time. The first question. Second question, what is Julio's rate in kilometers per minute? The question tells us how to solve it. Take your kilometers, divide it by minutes. Pick the easier numbers. I like these. Take the kilometers, 50. Here's what kilometers, I'll put it right here. Kilometers divided by 90 minutes. Distance divided by time, that's a speed, right? So we're going to cancel out the zeros. We're going to divide by 10, that gives us 5/9 kilometers per minute. I'm going to leave it as a fraction. If you were to divide that, you get what, AJ? Oh, it's 0.5 represent, but what were you going to ask?
I just wanted to say that I put 1527 as a thing.
And it gives you the same fraction. Excellent. So you could pick really either case. You would proportionate. This is our rate. I'm going to call this rate. This says I could go 5 kilometers, well, in 9 minutes. If I wanted my unit rate, I would divide that all the way to get a decimal. It's 0.5 kilometers per 1 minute. Now it says write an equation. Let's use a shortcut for our equation. There's two rate equations you should know. One is the dirt formula. Distance equals rate times time. What is the dirt formula? Get ready?
Distance equals rate times time.
Okay. Or you can use the other one, which is rate equals distance divided by time. I want to use this one. The reason why is because of the wording here. It says write an equation that relates Julio's distance to time. So I'm seeing, if we want to relate Julio's distance and relate it to time, I want to start with distance, and you'll see why. His rate, we got, was 0.5 repetend, or we could use 5/9 times time. Boom. Done. Okay, so what we did is we took his rate, we substituted in this equation. We are relating his distance to time, and all we know is his rate. We don't know exactly how long or exactly how far, but this would be a generic equation so we can figure out any distance for any amount of time riding. I probably would prefer the fraction, but I wanted to make sure you guys knew we were using the unit rate. Okay, any questions? I think you learned something new today. I can tell. All right, we're going to skip the ticket one. Just to recap, rate equals distance divided by time. What does rate equal to, class? Get ready?
Distance divided by time.
Distance divided by time. Those equations look like d over t, distance over time, but you might also see it how we did it, the dirt way, where you have a variable, and some constant. Variable, constant. So, here's a quick tip. If the question says, is this proportionate? If there's nothing being added or subtracted from it, it usually is proportionate. You just have to check to make sure there's no exponents. You need two variables. What is not proportionate? Right here. If you have something added, guaranteed it's not proportionate. Let me show you why. Let's take an equation that is proportionate. Okay? Maybe this is y equals 2x. Well, what if I add on to it a 5? Well, wouldn't this point I'd have to add 5 onto that? And this point I'd have to add 5 onto that. This point I'd have to add 5 onto that. So my new line would be shifted up 5 units. Does this new one go through the origin?
No.
No. So is this new one proportionate?
No.
The first part is, but once I add something, not proportionate. It doesn't go through the origin. That's your main concept today. Okay, so today we learned about unit rates. We solved more proportions, and we looked at proportionate relationships or not proportionate relationships. All right, let's do practice problems, page 333. Take a stand-up break.